Process versus thread explained. Beginner level. Introduction. When you run a program on your computer, the operating system creates something called a process. Inside that process, the program may run one or more threads to perform tasks. Processes and threads are fundamental concepts in operating systems and concurrent programming. They allow computers to run multiple programs and tasks efficiently. Understanding the difference between process and thread is important for learning. Multithreading, concurrency, parallel programming, operating systems. What is a process? A process is a running instance of a program. When you open an application, the operating system creates a process for that program. Each process has its own memory space, resources, file handles, execution environment. In simple words, process equals a program that is currently running. Example of a process. When you open applications such as a web browser, a music player, a text editor, each application runs as a separate process. Example: operating system, browser process, music player process, text editor process. Each process runs independently. What is a thread? A thread is the smallest unit of execution within a process. A process may contain multiple threads that run different parts of the program. In simple words, thread equals a task running inside a process. Threads share the same memory and resources of the process. Example of threads: a web browser process may use multiple threads. Example: browser process, UI thread, network thread, rendering thread, JavaScript thread. Each thread performs a specific task while sharing the same process resources. Process versus thread structure. Example structure: process, thread 1, thread 2, thread 3. The process manages resources, while threads perform the actual work. Key differences between process and thread. Feature: process thread. Definition: running program execution unit inside a process. Memory: separate memory space, shared memory within process. Creation: cost, heavyweight, lightweight. Communication: slower. IPC required. Faster. Shared memory. Isolation: strong isolation, less isolation. Failure: impact. One process crash doesn't affect others. Thread crash may affect process. Example scenario. Process example: running multiple applications. Process 1 means web browser. Process 2 means music player. Process 3 means text editor. Each process runs independently. Thread example: inside the browser process, thread 1 means load web page. Thread 2 means download images. Thread 3 means play video. All threads work together within the same process. Example in Python. Example using threads. Import threading. Def task. Print. Thread running. Thread equals threading. Thread. Target equals task. Thread. Start. Explanation: a new thread is created. The thread runs the task. Function: concurrently. Real-life analogy: think of a company. Process: the company itself is like a process. Each company has its own office, employees, resources. Thread: employees inside the company represent threads. They work on different tasks but share the same office resources. Advantages of processes: checkmark, strong isolation between programs. Checkmark, more stable execution. Checkmark, crashes do not affect other processes. Processes are useful when running independent programs. Advantages of threads: checkmark, faster communication. Checkmark, lower memory usage. Checkmark, efficient multitasking. Checkmark, better performance for concurrent tasks. Threads are useful when tasks need to share data and resources. Challenges: threads introduce several challenges. Crossmark race conditions. Crossmark deadlocks. Crossmark synchronization problems. Developers use tools like locks, mutexes, Semaphores. To manage thread safety. Where processes and threads are used. Processes and threads are used in many modern systems. Operating systems, web servers, game engines, mobile applications, cloud computing systems. Examples. Web browsers use multiple processes and threads. Servers use threads to handle many users. Operating systems manage processes for applications. Simple definition. Process. A running instance of a program with its own memory and resources. Thread. The smallest unit of execution within a process that performs tasks. Final summary. Processes and threads help computers run multiple tasks efficiently. Checkmark process equals independent running program. Checkmark thread equals task running inside a process. Processes provide isolation, while threads provide efficient multitasking. Both are essential concepts for building modern concurrent and high-performance applications.